There we go. For the first question, right, question one, the net ionic equation for the complete neutralization of HCl by KOH, right? HCl is a strong acid, KOH is a strong base. So our complete ionic equation would be the proton plus chloride, potassium hydroxide yields potassium chloride and water, right? Making our spectator ions, the potassium, the chloride, potassium chloride, any strong acid, strong base neutralization reaction. The net ionic equation will always be proton plus hydroxide yields water. So in these questions on the exam, just make sure you read what you're asked for and answer what you're asked for. Is it the complete ionic, the net ionic? You know, what equation are we being asked for? Which of the following compounds are soluble in water? We've got lead hydroxide, I've got strontium sulfate, I've got sodium sulfate, mercury chloride, right? If we go to the solubility table, which is not here, yeah, my mistake. Glad I recorded that. All right, if we go to the solubility table, mercury chloride is insoluble. All metal hydroxides, except for group 1 metal hydroxides, are insoluble. Strontium sulfate is insoluble, right? The only thing that would be soluble would be sodium sulfate. Sodium sulfate would be soluble in solution. Let's see, I can insert the, let's see, right there. I just want the last page. All right, so the choices we had were strontium sulfate, lead hydroxide, and mercury chloride, right? We can see that hydroxide is insoluble unless it's a group 1 metal or calcium, barium, or strontium. So lead hydroxide would be insoluble. Chloride is soluble unless it's with mercury. We've got mercury, so it would be insoluble. And the sulfates are soluble unless they're silver, calcium, or strontium. We have strontium sulfate, so all three of these would be solid. They would not go into solution. However, sodium sulfate would go into solution. All right, question 3, aqueous sodium chloride will react with which of the following in a precipitation reaction? So we want to look for chloride, right? Chloride would precipitate with silver, lead, or mercury in solution. So that should be pretty straightforward. We're going to look for something that has silver, mercury, or lead. All right, sodium sulfate, no. Potassium bromide, no. Lithium acetate, no. Ammonium sulfate, no. We've got lead nitrate there. So yes, I could precipitate lead chloride in this example because again, we know only these three things would force the precipitation of a chloride from solution. All group 1 metals are always soluble, so there's nothing we could add to precipitate sodium. Sodium won't react with anything. Chloride, however, could react with silver, mercury, or lead. All right, question 4. Question 4 is a tricky question. It is a little bit harder than the other questions we've looked at so far tonight. Which reaction does the oxidation number of hydrogen change? And to answer this, we could assign oxidation states to everything in this reaction, and I'll do that for the first choice, but then after that, I'm going to kind of give you a shortcut to look for. So if I want to assign oxidation states to everything in this reaction, right? In HCl, the proton's +1, chloride's -1, sodium would be +1, hydroxide is -1, sodium again is +1, chloride's minus. In water, right, hydrogen would be +1 each, oxygen's -2. We could see the same thing in hydroxide, right? If I split apart hydroxide, oxygen is -2, and I've got a proton at +1, making the whole thing -1. So in this first reaction, oxidation states are the same because hydrogen is +1 here in HCl, and it's +1 here in water. It's +1 in hydroxide, right? Hydrogen has the same charge in all of these. We could do the same thing for the rest of these reactions, but one of the hints I gave you to find a redox reaction is look for a pure elemental solid that becomes aqueous, right? That's a clear sign that there's a redox reaction taking place. This pure elemental solid, sodium, is 0. In sodium hydroxide, sodium is +1 because the hydroxide is -1. So the charge on sodium is changed, which means the charge on something else needs to be changing as well. So if we take water, right, water has to add up to 0, but within water, right, I've got 2 hydrogens at +1 each, oxygen at -2, right, for my overall charge of 0. In hydrogen gas, any diatomic, right, the charge on the diatomic is 0, and each hydrogen has to be 0 because it's H2. I can't say one hydrogen is +1, one hydrogen is -1. The whole thing is neutral, and we can't assign a charge to either hydrogen. So this case, the oxidation state of hydrogen has changed. The charge on hydrogen has changed. We go from +1 in water to 0 in diatomic hydrogen. We could assign the rest of the charges in C, D, and E, and we would see that nothing else changes. None of these reactions are precipitation or redox reactions, with the exception of the reaction B here. All right, question 5, then we'll take a break on our recording. All right. What are the spectator ions? Have I missed any questions? Nope, looks like we're good. What are the spectator ions in the reaction between sodium sulfate and barium chloride, right? So sodium sulfate reacts with barium chloride, aqueous, and that's going to get us give us more room to work with here. Sodium sulfate, aqueous, barium chloride, aqueous, 2 possible products, right? We bring the outer together, and I dropped the 2 there. So the outer 2 products, right, would be sodium chloride. We know sodium chloride is always soluble. That's aqueous because sodium's a group 1 metal, always soluble. The other possible product is barium sulfate. So we're going to go to our solubility table, right? We know that sodium chloride is always soluble, so we don't have to worry about that. The sulfate, we go down here. Sulfate is soluble unless we have barium in solution. We have barium in solution, so we're going to precipitate a solid barium sulfate. We can ionize everything now, right? 2 sodiums, sulfate, barium 2 plus, aqueous, 2 chlorides, aqueous. That yields 2 sodiums, 2 chlorides, and a solid barium sulfate. We cannot ionize that because that's a solid. To get our net ionic equation, we eliminate our spectator ions, right? Our spectator ions go through this unchanged. I guess we can't read that here, right? What are the spectator ions for this reaction? So the spectator ions, right? Sodium is the same on both sides. And if we look, chloride is also the same on both sides. So our spectator ions in this reaction are sodium and chloride. Can't be this because barium sulfate's what's precipitated, right? Can't be anything with sulfate, can't be anything with barium. So it's choice D, right? The sodium chloride are our spectator ions. They went through the reaction unchanged. Did not participate in the reaction.